Welcome to section 4.1 in our OpenStax statistics book, and this is our first video. In this section, we'll be talking about discrete random variables. If you recall from an earlier chapter, discrete data are data that you can count. A random variable is a description of the outcome of a statistical experiment in words. We usually use uppercase letters for a random variable, and lowercase letters are used for the value of the random variable. Let's take a look at example 1, and suppose you're tossing a coin again, and you want to determine the probability of getting 3 heads when you toss a coin 3 times. We can define the random variable x here, and we would let x equal the number of heads. Notice that we use the capital letter X here for the random variable. Now, what values does the random variable x take on? For this, we would use the lower value, lowercase of x. We could get 0 head, 1 head, 2 heads, or 3 heads. Let's move on to the next page, and we'll begin section 4.1. Let's recall a couple of characteristics of a probability distribution function. And remember, each probability is between 0 and 1, including 0 and 1, and the sum of the probabilities is 1. And we'll begin using this notation here to show the probability of the value that our discrete random variable takes on. So let's go ahead and consider example number 2. Where a hospital researcher starts recording the number of times a post-op patient will ring for the nurse during a 12-hour shift. We have 50 patients, and our variables for this exercise are 0 times, 1 time, 2 times, and so on to 5 times. So what is the probability that a patient will ring the nurse 3 times? Well, let's look for where our random variable is 3. Here it is. And what is the probability at 3? And it equals 14 out of 50. What is the probability that a patient rings the nurse more than once? So that means we would take twice, 3 times, and 4 times, and we would add all of these together. We would write more than once like so, using our inequality signs. And we would add up how many times a patient rings twice, and 3 times, and 4 times. And this will equal 38 over 50. Next, they ask, what does this notation here represent? And go ahead and find it. Well, this means what's the probability that a patient will ring less than or twice, meaning 0 times, 1 time, or 2 times. So let's go ahead and find that. So the probability of 0 times is 4 out of 50, and 1 is 8 over 50, and the probability of 2 is 18 over 50. Keep in mind, we are allowed to let x equal 2 here, and I used these values here to get the probabilities. And once I go ahead and I add that up, we will get 30 out of 50. And what does this represent? This is the probability a patient rings at most twice. Now, Letter D asks, why is this a discrete probability distribution? Well, we'll go up to here for the two characteristics we need for a probability distribution function. And is each probability between 0 and 1? Let's look here. Yes, it is. All of those are decimals between 0 and 1. And are the sum of all these probabilities 1? Well, let's check that out. So we'll take all of our probabilities and we'll add them up here. And when we do, we will get them to equal 1. Let's move on to the next page. And we see an example about Jeremiah's team and how often he practices during the week. Each week he has to practice 3 days a week. 85% of the time he makes each practice. 10% of the time he attends 2 practices, and 3% of the time he attends only 1 practice. Define the random variable x here. And x, our capital X, would be the number of days Jeremiah attends practice each week. Next, we're asked for what value does x take on. And now we're going to use our lowercase value for x. He can attend 0 time, 1 time, 2 times, or 3 times per week. Next, we're asked to construct a probability distribution for this data. So we'll create our probability distribution table, and let's go ahead and fill in the data we were given here. We were told 85% of the time he attends all practices, so that means when we know he attends 2 of the practices 10% of the time, and just 1 of the practices 3% of the time. And then they don't come out and tell us how many he attends when he misses practice completely. But we know that in a probability distribution, all the probabilities have to add up to 1. It means only 0.02 or 2% is left here. And that's how we construct our probability distribution table. Lastly, we're asked to find the probability that Jeremiah attends less than 3 practices in a week. So we would need to write that like this, less than. We won't include the line under the less than, and that means he can attend 0 times, 1 time, 2 times, and if we add all of those up, we could get 0.15. And you could also take the complement of this if you wanted to, meaning you would just subtract the probability of 3 from 1. And that's the end of our video for 4.1.